So, a very good morning to all of you. So, students, how are you people? I think you all are fine. So, now today we people are going to learn third chapter of standard 10, that is pair of linear equations in two variables. Okay. So, before learning pair of linear equations in two variables, let us recall some linear equations which we have learned in the previous classes. So before linear equation, we have learned about polynomials. Or we can say we have learned about an algebraic expression. Okay. You must be familiar with these words. Okay. Now, in polynomial, we have seen that consider a polynomial ax plus b, or let us consider a polynomial 4x plus 5. Now here we can decide that what type of polynomial is this one. Okay, by knowing the degree of this variable, it can be easily identified that this polynomial is a linear polynomial. Okay, now if we write the other side of this polynomial by adding equal to, we can write here any number. Now this has a change into an equation. Now since the degree of this variable is 1, so now this equation is known as a linear equation. Okay. Now in this chapter of 10th standard, we people are going to deal with linear equation in two variables. Right now here only one variable is present, so we can say that this one is a linear equation but with only one variable. So let us consider an example 4x plus 5y equals to 10, or we can say that 2x plus 3y minus 7 equals to 0. Now these two are nothing but pair of linear equations with two variables. Okay, here it can be seen that x is one of the variable, y is another variable, so this one is an equation, okay, in which two variables are present. So we can say that this one is a linear equation with two variables. Okay, no problem whether on the other side a number is present or not. Here we have one more example, 2x plus 3y minus 7 equals to 0. Here also we can see that two different variables are present, so this one is also an equation with two variables. Now we are going to learn about pair of linear equations in two variables. Now you are already familiar with what is a linear equation in two variables. Pair means we have to write two equations, so it will become a pair of linear equation in two variables. Let us consider an example 2x plus 3y equals to 5. Now this one is an equation. Okay, it is a linear equation because the variables, their power is 1. Okay, if no number is there, it means that the power is 1. So this one is a linear equation with two variables. If we write one more equation with this one as 5x minus 4y equals to 21. Now this pair, now this one is also an equation, a linear equation with two variables. Remember that both the equations are having same variable, so we consider that now this together are forming a pair of linear equations in two variables. Is it clear? So now I think it must be clear to you that what is a pair of linear equations in two variables. Is it clear? Now next we are going to learn, let us recall that in the previous class we have learned that how to find the solutions of a linear equation. Okay, so the standard form of a linear equation can be written as ax plus b equals to 0. Let us consider an example. Suppose if it is given as 4x minus 12 equals to 0. For finding solution of this one, what we do, we just move all the numbers on the other side. We do not keep any number with this variable x. So what is the first step? 4x equals to, we move this minus 12 on the other side. So if it goes on this side, it will become plus 12. Then now we move this 4 with x on the other side. Okay, so x equals to 12 upon 4, x equals to 3. So now here it can be seen that we are having one solution, okay, that is x equals to 3. From this we get a conclusion that in linear equation with one variable we get only one solution. Only one solution. But now in pair of linear equations with two variables, we can have some different types of solutions over here. We cannot say that we can have only one solution. Why? Because we can let us learn with the help of a graph. We know that for any equation we can draw one graph. Okay, so let us consider that this one is a line for this equation, okay, and this one is a line. Let this one be line x and let this be line y. Now this is a line for this equation. Now when we draw it together or extend it together, we get three possibilities. When we draw this both the graph on the same paper, okay, we get three possibilities of these two lines. Okay, the first possibility is that both the lines, they will intersect each other at any point. Okay, let them intersect. Now line x and line y, let them intersect at point P. Okay, the second possibility is that the lines, suppose now this one is line x, it is moving in this way, and line y, it is also coming from this side. Okay, so we can say that both the line x and line y, they coincide. Coincide means they meet at the same point. Okay, so here we do not say that they intersect, we say that they coincide. Okay, so let them coincide at point Q. Then we get a third possibility for the graph of these two equations, that is first line x may go in this way, the second line y, it may go parallel to the first line. Okay, so these are the three possibilities when we draw a graph for a pair of linear equations in two variables. For this equation we can have this type of three graphs. Okay, in the first graph the two lines, they are intersecting. In second graph the two lines, they may coincide. Okay, and in third one it can be seen that the two lines, they may run parallel to each other. Okay, now based on the nature of this graph, that is whether they are intersecting at a point, they coincide at a point, or they are parallel to each other, we can decide that how many solutions it can have. For example, if two lines are intersecting each other at a point, we can say that it will have only one solution. Okay, then when two lines, suppose this one is line x and this one is line y, when they coincide at a point, that is when they meet at a point, we can say that during such a condition we can have infinite solutions. that is infinitely many solutions are possible when two lines they coincide each other. Then the next possibility is that when two lines, if they run parallel to each other, during such a condition we have no solutions. Okay, no solution is possible when the two lines are running parallel to each other. Now I think you must have understood that by drawing the graph we can decide, by drawing graph for the pair of linear equations we can decide that how many solutions are possible. First thing is that we can decide the nature of the graph. Nature of the graph means whether the two lines are intersecting, whether they are coinciding, or whether they are running parallel to each other. And then by knowing the nature of the graph we can decide that how many solutions are possible. That is, if the two lines are intersecting each other we can say that only one solution is possible. Then if the two lines are coinciding each other we can say that infinite solutions are possible. But when two lines are running parallel to each other then no solutions are possible in such a case. But every time we cannot draw the graphs and decide whether the graphs, whether what type of solutions will be there. Okay, so instead of drawing graph we can also find by finding the ratio of a1 upon b1 now we can also decide that how many graphs, how many solutions are possible by finding the values of some ratios. Okay, so I'm writing that ratios over here. So now let us write it here. Okay, so now by finding the ratio of a1 upon a2, b1 upon b2 and c1 upon c2 we can decide that how many solutions are possible. Now you must have a question that what is a1 upon a2, b1 upon b2 and c1 upon c2. So this equation, that is, let us write the above linear equation in its standard form. Okay, so we can write it as a1x plus b1y plus c equals to 0. Now this is the standard form of a linear equation with two variables where x and y are the variables and a1, b1 and c1 are any real numbers. a1, b1, c1 are any numbers. Is it clear? Now as we are learning pair of linear equation with two variables, so we need to write the equation for the second, we need to write second equation also. So the second equation will be a2x plus b2y plus c2 equals to 0. Now this is the standard form of a pair of linear equation in two variables. Now from here we get a1 means it is nothing but the coefficient of x, b1 is the coefficient of y and c1 is the constant term for the first equation, and a2 similar coefficient of x, b2 coefficient of y and c2 constant term for the second equation. Okay, now from this we can get the value of a1 upon a2, b1 upon b2 and c1 upon c2. But now how to decide that how many solutions are possible? Just like here we have seen graphically we can decide whether one solution is possible, infinite is possible or no solution is possible. In that similar way, by knowing the ratios and the relation, that is a1 upon a2, b1 upon b2 and c1 upon c2, by knowing their relation we can decide that whether one solution is possible, or infinite solution is possible, or no solutions are possible. Okay, so now for that we have to find the ratio of a1 upon a2. Let us consider one example. Okay, so now in this example here we are having an equation that is 5x minus 4y plus 8 equals to 0 and 7x plus 6y minus 9 equals to 0. For finding solution, be sure that these equations are written in a standard form, that is all the numbers are on the left hand side. Okay, so here the constant term is also to the left hand side, here also the constant term is to the left hand side. After getting it confirmed, now first we have to decide that what is the value of a1. So here a1 equals to 5, b1 equals to minus 4, and c1 equals to 8, and a2 equals to 7, b2 equals to 6, and c2 equals to minus 9. Now let us try to find the ratio. So here we get that a1 upon a2 is equals to 5 upon 7, then b1 upon b2 is equals to minus 4 upon 6. So let us write this one in lowest form, so we get it as minus 2 upon 3. Now next one is c1 upon c2 is equals to 8 upon minus 9. Now from these ratios it can be seen that a1 upon a2 is not equals to b1 upon b2, and is also not equal to c1 upon c2. So since all of them, all the three ratios are not equal to each other, in such a condition we can say that the given pair of linear equations will have intersecting lines, and it will have only one solution. Okay, so we can write it as, therefore given lines, or you can say that given equation will have only one solution. In other words, we can say that it will have a unique solution. Is it clear? So based on the ratio, okay, and their interrelation with each other, we can decide that how many solutions are possible. Okay, so we are having that. Now let us consider another example. Now again we have to decide what is the value of a1, a2, b1, b2, and c1, c2. So solution here, a1 equals to 3, that is coefficient of x, comma, b1 equals to 2. Now remember that here in this equation the constant term is present on the other side. So if in first equation if it is present on the other side, here also it should be on the other side, otherwise you have to bring it on the same side. Okay, so now since both of them are on the same side, or that is on the other side, so we can keep this one as it is. Now so we have a1 equals to 3, b1 equals to 2, we can write it as c1 equals to 5. Similarly a2 equals to 2, b2 equals to minus 3, and c2 equals to 7. Remember, again I am telling that since here 5 is present, that is a constant term is present on the other side, and here also on the other side. So we can directly consider these values as C1 and C2. If they are not present on the same side, then we have to bring it on the same side. Is it clear? So now the next step is that we have to find the ratio of A1 upon A2. So A1 upon A2 equals to 3 upon 2, B1 upon B2 is equals to 2 upon minus 3, and C1 upon C2 is equals to 5 upon 7. Now again we can write that, since it can be seen that the ratio A1 upon B2, B1 upon B2 and C1 upon C2, none of these ratios are having same values, that is, these all are having different values. So we can write that A1 upon A2 is not equal to B1 upon B2, and this one is not equals to C1 upon C2. Therefore we can write that given equations will have only one solutions, that is unique solutions. So given pair of equation have a unique solution. So in this way, by knowing the ratio, that is of A1 upon A2, B1 upon B2 and C1 upon C2, we can decide whether it will have one solution, infinitely many solutions, or no solutions. Okay, but there is some condition, there are some conditions. Okay, so let us look further. Now suppose if it is given that, let us consider two lines having equations as a1x, b1y and c1 equals to 0, a2x plus b2y plus c2 equals to 0. Now if the ratio of a1 upon a2 is not equal to b1 upon b2, if this much condition is also there, then we can say that the two lines are intersecting. Okay, and when the two lines are intersecting, okay, we can say that they are consistent also. Consistent means we can get a unique solution. So I am writing here that if a1 upon a2 is not equal to b1 upon b2, then the two lines are intersecting and it will have exactly one solution. Only one solution is possible for this condition. Then if the ratio of a1 upon a2 is not equal to b1 upon b2, if the ratio of a1 upon a2 is equal to b1 upon b2, and next it is also equals to c1 upon c2, that is all the three ratios are equal to each other, then during such conditions we can say that the two lines are coincident and they are again consistent. Okay, consistent means when the two lines are coincident, during such a condition we can have infinite solutions. Is it clear? So here it can be understood that, again I am telling that when the ratio of a1 upon a2, b1 upon b2 and c1 upon c2, they all are equal to each other, then the given two lines, or we can say that the given pair of linear equation will have infinite solutions, and the two lines will be coincident, that is they will meet at a point. Now you must be wondering that what is the meaning of this consistent. Consistent means whenever we are getting at least one solution, we say that the two lines are consistent. If one solution is there, then also the lines are consistent. If more than one solution is there, then also the lines are said to be consistent. So the condition is that if you get a solution, the lines are known as consistent. Okay, then if we do not get a solution, then we can say that the lines are inconsistent. Now in this third case we can see that if the ratio of a1 upon a2 is equal to b1 upon b2, but these ratios are not equal to c1 upon c2, then we can say that the two lines will be parallel to each other. Without drawing the graph, we can decide the nature of that graph, that is the two lines will be parallel to each other, and they are inconsistent. Why they are inconsistent? Because during such a condition no solutions are possible. Is it clear? So hope you must have understood up till here. Now let us try to solve some more examples based on this one. So I have given some homework for you people. You people have to solve exercise 3.2. No need to solve this question. I'm just marking this one. So you can directly start solving from question number 2, question number 3 and question number 4. Okay, so this much is enough for today. Thank you. Have a nice day.